me begin with kind of just the general overview of what you should expect on the final exam for either Stat 2401 or for Business 3000. It is virtually the same course, and so I have both classes in the room tonight. So even though it may say Business 3000 or Stat 2401, it's all the same. So I am going to share my screen. And this document that you're seeing is posted in the announcements about the final exam. The final exam for both courses is not proctored, which means you will not be using Respondus Lockdown Browser. That also means that you can use any handwritten notes that you've made, created throughout the course, the flow charts that have been available in the course, the PowerPoints, the practice problems or homework problems during the final exam. You will need to access and use Minitab during the final exam. Unlike the midterm, you have to actually enter the data and walk through the commands in Minitab to get your results. Okay. You should have two documents that I posted in the discussions for Module 3 and Module 4, which have basically the keystrokes for everything that's covered in Module 3 and Module 4. The final exam will open on Thursday, July 28th in 2 days, basically at midnight, and it closes on Monday, August the 1st at 11:30 p.m. You are allotted 3 hours to take the exam, okay? And that has to be in one sitting, guys. You can't start, stop, start, stop. It is not going to cut you off after 3 hours. It simply will notify me, and probably you, that you took longer than 3 hours. The only way you get completely cut off from the exam is if you go past 11:30 p.m. on Monday, August the 1st, because the document closes and you will not be able to do any more. So please do not wait till 8:30 Monday night to start the test. Okay, not a good idea. There's only one attempt on the final. There's no makeups. It'll be a similar layout to what you saw on the midterm. It has multiple choice and fill in the blank questions. Probably some of the biggest issues that students have is following the rounding guidelines. So just be careful, make sure you read whether you're supposed to round to the whole number, to 2 places, to 3 places. I will tell you that when you submit your final exam, you will not automatically see a grade. Again, because the fill in the blank questions, I have to go in and look at, okay, to see if you spelled it right. Did you put the leading zero like 0.05? Because if you don't, sometimes D2L will count it wrong, okay? And I go in and give you credit for those things. So once the exam opens on Thursday, I will be monitoring submissions and grading them as they come in. Okay, and so once I've graded it, then I release your grade and you'll be able to see what you made. The final exam only covers content from Module 3 and Module 4. So here's the layout. There are 10 sections on the final exam. The first one covers normality, which is 5 questions. You have a one mean hypothesis test. It could be either a Z or a T. You'll have to decide. You have a chi-square goodness of fit. You have analysis of variance, that's section 4. Section 5 is correlation and linear regression. 6, you have a 2 mean hypothesis test. 7 is a 1 proportion hypothesis test. Section 8 is 2 proportion hypothesis test. Section 9 is a chi-square test of independence. Section 10 is chi-square test of homogeneity. Each question is worth 2 points. So that probably, I haven't added that up, but I would say that adds to 75 questions for a total of 150 points. If you have looked at the final exam review that you can do for 10 bonus points, the layout of that review is exactly the format that you'll see on the final exam. It is the same order. It is laid out in these sections. And I know that for a fact, 1, because I created it, 2, because I actually took the review this afternoon. Jody, go ahead.
Hey, Professor, sorry to bother you, but
it's okay.
I just had a quick question. So, and I just want to make sure I understand it. So, because it'll help me with my notes that I prepared for the semester. You have it listed on our Stat 2401 breakdown.
Yeah.
In sections 1 through 10.
Yes.
Is that actually the order so that I will know where to pull my notes from so that I'll know that the first 5 questions are going to be normality, so I pull my normality notes?
Yes.
Perfect. Thank you. I'm sorry. That was my biggest question.
Even the review, if when you get a chance to take a look at the review, it follows this layout, this layout. So it's exactly the layout. So if you want to organize your notes so that you have normality first and so forth, that's going to be a great way to go at it.
That's why I wanted to ask, because I thought that would actually be beneficial. And I am going to do the practice exam. So I just want to have all my ducks in a row.
I will also tell you, because I realized this afternoon when I took it, because I scored like 59 out of 72. And I thought, now, wait a minute. But there again, it's because you have some of those fill in the blank questions. So once you guys take it, I'll look at it. You're getting 10 points simply for doing it. So, but I'll go in and make sure you know, oh yeah, I got this right. And again, a lot of it's just because if you don't put the leading 0, it'll count it wrong and that kind of thing. So
yes ma'am.
Don't panic if you get a weird number for the score, because the 10 bonus points is simply the fact that you attempted.
Yes ma'am. Thank you.
You're welcome. Other questions related to this kind of general information about the final exam?
Professor Rawson, are those review questions going to be like the same as the test or no?
Yes, they are worded, formatted in the same order that they will appear on the final exam.
Oh, okay. Awesome. Thank you.
You're welcome. Other general questions? Okay, do you have content questions then that you want to ask about any of those topics? If you have taken a look at the review, you're free to ask questions. I'm really surprised that I don't have more students in the room, but I don't know why they chose not to participate. But do you have questions from either the review, from the quizzes in Module 2, Module 3, Module 4, a general content question?
Professor, does that mean that the 7 of us on here get extra credit? Are we going to be teachers' pets?
Y'all might be teachers' pets, and you might really wind up doing really well on the final too, because you spending the time to get the help.
Yes, ma'am. Sorry.
It's okay. Also, remember you have mini project number 7, which is related to chi-square, goodness of fit, or chi-square period, whether it's goodness of fit, test of independence, or homogeneity. It's due tomorrow. Okay. Some of you have already submitted that. If you have, I've looked at it. And if you had issues, I've sent it back to you. I'm trying to look at the list of names. I don't see anybody's name that I've sent it back to yet. But If you submit it early and I look at it and realize, oh, they have some issues, I send it back to you so you can look at it again. Okay, so I was working on grading those before it hit 7 o'clock. But do you have specific content questions?
I actually did have a question about that project. Just like my hypothesis and my calculations, I thought I did the calculations right.
Well, it depends. For mini project number 7, you're dealing with chi-square. Let me go over here. Let me share my screen and go over here and make a few notes that might be helpful. You get a blank screen. Okay, when you're looking at chi-square, which is the last topic that we have talked about in the course, that those assignments are due tomorrow, there are 3 different tests for chi-square. If you had, and all of you should have had, Math 14 or Stat 1401, we talk about goodness of fit. Okay, that's in 1401. It's also in 2401 and Business 3000. Okay, but we also talk about, in these courses, we talk about the test of independence. And we also talk about the test of homogeneity. Now, the way you state the hypothesis depends upon which test you're doing. It also controls or determines the commands that you use in Minitab. So you have to identify, when you're working on the project, the first question asks you, which test are you going to do? Because then, based on what you tell me from there, I know how you need to word your hypotheses. DJ, are you with me?
Yes, ma'am. Because I used the test of independence.
Okay.
I tried to find an example in those videos, on module 4 or whatever, module 4.
Yes.
And I tried to base my hypothesis to your examples, and I thought I did it correctly, but I guess not. And then I'd seen the video that you posted where you kind of do all 3 of them.
Okay, one issue, and I honestly, I don't remember if it was yours because I've been looking at a bunch of them for the last couple of days. Okay, first of all, you have to remember that chi-square is dealing with qualitative data, words, not numbers. Okay, if you're doing chi-square goodness of fit, you only need 1 variable. If you're doing test of independence or test of homogeneity, it's 2.
Professor, when you say that, are you saying, when you say 1 variable, you're meaning 1 of numeric value, 1 of word value, correct?
I'm saying 1 word.
1 word, okay.
We don't mean good. Chi-square goodness of fit is strictly words.
Words, yes, ma'am.
Okay, so let me see if I can pull up, and I'll try to work an example of each one of these. That may be helpful for DJ, so he can kind of get an idea of what he needs to do, what he's looking for, that kind of thing. Okay, so I'm going to pull up. I can just pull up the quiz for that. It doesn't matter. Okay, so quiz 12. I have to preview. Okay, so this is the quiz 12 on chi-square test. And so the first scenario that I see, and I'm going to copy this because it'll make it easier for me to talk about it.
I'm not sure. Sorry, Professor. I'm not sure everybody else is having an issue, but it just says the wheel of death that you started sharing your screen. I'm not seeing anything but a black screen.
Oh, okay. Let me stop
I
my
see you in the top, but it's not in the.
Okay, let me stop the share and I'll try again. Let me try again, Brandy. Thank you for letting me know. Okay. What you seeing now? Do you see it? What? My Word document?
I'm still seeing the. No, ma'am. It's still the quill of death.
I'm seeing your copy and paste.
Okay, so you can see my Word document, Jody?
Yes, ma'am. I sure can.
Okay, Aubrey, can you see the question?
Yes, I can see it.
Brandy, are you on a computer or a tablet?
I'm actually on my phone at the moment. I was going to log out and log back in and see if that fixes it.
Okay, why don't you try that for me, hon?
All right, thank you.
You're welcome. All right, so here's the first question on quiz 12. So it says M&M's Mars Company, the maker of Skittles, state that each bag of Skittles has the same number of each flavor in it. Use a 0.05 level of significance to test the company's claim. Below is the observed number in a bag of Skittles. So we buy a bag of Skittles, we open it up, and there are 4 lime, 15 lemon, 12 orange, 20 strawberry, and 4 grape. That's what we observe. So one of the first decisions you're going to have to make is, which chi-square test am I doing? So one of the things that jumps out at me is that we're only talking about one thing. I'm only talking about the flavors of Skittles. Okay, so my variable here, if you want to be real specific about it, because you have to pick a variable from your data set when you're doing your project, my variable here is the flavor of Skittles. That's my variable. And guys, hopefully it makes sense that those flavors are words: lime, lemon, orange, strawberry, and grape. That makes it a qualitative variable. Okay, my variable is qualitative. If you want to think about it, you have categories. And in this case, you have 5. You have lemon, lime, orange, strawberry, grape, and so forth. Okay, so because I have only one variable, that is my clue that in this case, I need to do chi-square goodness of fit. Now, if you read between the lines or read again, thinking about the scenario, it says in the first sentence that the Mars Company claim that each bag has the same number of each flavor in it. Okay, so we want to determine, does what the Mars Company say fit what we have observed when we opened our bag of Skittles? That takes a little bit more reading between the lines. Okay. So with any I've decided I've got to do chi-square goodness of fit. That is one of the questions that they usually ask on the review, and on the final it's going to say, which test are you conducting? Okay, so for this test I am doing, or for this problem, I am doing chi-square goodness of fit. The first step in any hypothesis test is to state the hypotheses. And guys, one of the things that a lot of you seem to have missed throughout this whole deal of talking about hypothesis test is that the null hypothesis must contain equal in some form, and the alternative will be not equal. And quite honestly, for chi-square goodness of fit, those are the only two options. The null will have to imply that it is equal, and the alternative will imply that it is not. Your hypothesis is actually given to you in this scenario, because what you expect is the claim being made by the Mars company that all the categories of flavors are the same, that you have the same number of each flavor in the bag. Okay, so if we're saying all the categories of the flavors are the same, does that imply equal or not equal?
Equal.
Equal.
That's equal. And guys, you literally can write it this way. All the categories of flavors are the same. Don't try to get fancy dancy. It's right there in the problem. Use it. Okay, so that's our null, because this word same should imply equal to you. And because it implies equal, it has to be the null. The alternative then, we usually will say at least one category of flavor differs. You could say all the categories are not the same. There's lots of ways to say it, but however you say it, you have to imply that they're not the same. Okay? Then we're ready to go out, and I need to write this down. We got to go out to Minitab, and I'm going to enter my information. I have to enter those observed values. So I'm scribbling them down on my piece of paper. You may want to have some paper handy when you're taking the test. And then we're going to go out to Minitab. Okay, so the first step is to state your hypotheses. Then you usually identify the information you need. Well, in this problem, the information is given to us because right here's what we need. We need the observed. So I'm going out to Minitab. And let me get a new worksheet. Okay, and on my worksheet, I'm going to put the flavors of the Skittles in column 1. So I have lime, lemon, orange, strawberry, whoops, spelled that wrong, and grape. And then next to it in column 2, I'm going to put the count or the observed. This is the observed count. I had 4 lime, 15 lemon, 12 orange, 20 strawberry, and 4 grape. Okay, so you will have to physically, just like I did, typing it in myself, do that for the final exam. Okay, then we go to Stat, Tables, chi-square goodness of fit. My observed counts are in column 2. My category names are in column 1. And that was from the other assignment. We are assuming they're equal because we're saying they're all the same. So they're equal proportions. And we click OK. Whoops. I'm doing this one. Thank you. Okay, so then we get our results from Minitab. I've got to scroll down. And right here, it gives me my answer. And I'm trying to paste it, so hold on. Okay, so according to Minitab, my chi-square value is, let me go back to draw. Oh, you're not liking me, huh? Okay, my chi-square value is 17.8182, and the p-value is 0.001. So now I have my test statistic, which is the chi-square. I have the corresponding p-value. I'm ready to make a decision. It tells me in the problem to use a 0.05 level of significance. So I've got to compare the p-value from Minitab to the level of significance which was given in the problem. We make that comparison digit for digit. So the first digit after the decimal is a 0. The second digit for P is a 0. For alpha is a 5. 0 is less than 5. So alpha is less than or equal, or excuse me, the p-value is less than or equal to alpha. If the p-value is less than or equal to alpha, we always and forever reject the null. So if that means if we reject the null is false. So in this context, we have, based on the evidence we have, our null is false, which means all the categories of the flavors are not the same. Okay, so the claim that the company's making is incorrect. So then we would write our conclusion. Your conclusion is always stated in terms of the one of the hypothesis that is true. So we would say at the 0.05 level of significance, all the flavors of Skittles are not the same. Based on the evidence that we have. See, if I go out and buy a different bag of Skittles and do the same test, I could get a different conclusion. See, I'm basing it on the evidence that was given to me. Okay, that's chi-square goodness of fit. Questions?
No, ma'am.
So,
Aubrey, you okay? DJ?
So for the observed, you use like a quantitative variable?
No.
The count?
I have a count, but that's not a different variable. I literally opened my bag of Skittles, poured them out on a plate, and then I put all the limes together, which would most likely be green. So I put all the greens together. I put all the yellows together, all the orange, all the red, and all the purple. And then I counted them.
Gotcha. Yeah. No, yeah.
I'm not using a separate variable. I just counted the flavors in the bag so that I have those observations.
No, I totally understand. I guess I'm just saying for like the mini tab purposes, like
I'm still not using two variables. Now, if I'm doing test of independence or test of homogeneity, I might be.
Okay.
Okay, so let me see if I can find an example for one of those. That was scenario 1. Okay.
I think I know what you're saying. I think I did the same thing on my mini project. I got confused and was trying to find another variable with a number. And I should have just basically, like you said, take out the bag of Skittles and count 1, 2, 3, 4. So I think that's the same, if I'm understanding right.
Yeah, yeah.
I think you're having the same issue I was having.
For goodness of it. Okay, scenario 2 here, if you look at scenario 2, it is also a goodness of fit test, but instead of saying that all the categories are equal, it gives you specific percentages for each category. Okay, I'll come back to that one in a minute. Or do you have a question?
I think that what we're seeing is, I guess we're getting gun shy because when we see a number, we think quantitative.
Right.
And so, but in this situation, it's not the case. I mean, because the qualitative data is like superior because it's like laying the groundwork. Yes, it has numbers equated into it, but you're based off of qualitative data, not quantitative.
Yes.
Am I saying that right? I mean, that's the way I'm trying to see it.
That's kind of what you got to look at. That for chi-square, your focus should be the superior one is going to be the qualitative, and it's going to be categories. And you can, and I'm looking for one. I'll come back and do that one if you guys need it. Each category. Okay, that's still goodness of fit. Okay, scenario 4, and let me see if I can copy this and hopefully it'll copy correctly. Whoops. I'm trying to make sure I get it all. Okay, this data, paste. Oh, thank you. Okay, is going to be the chi-square test of independence. Okay, kind of look and see how this one is different from the one we just did. It says college students may be interested in whether or not their majors have an effect on starting salaries after graduation. Suppose that 300 recent graduates were surveyed as to their majors in college and their starting salaries after graduation. Okay, you actually have two variables here. You have majors, which I hope you realize are words: English, engineering, nursing, business, and psychology. And we're trying to say, does it have any effect on starting salaries? Now, this is where it might get a little hinky for you, because salaries, you're thinking money. Okay, but the way this is set up, they have it set up in categories. Think about it like if you ever do surveys, you know, it'll say, you know, what is your salary range? Okay, so they kind of have created categories: less than 50,000, between 50,000 and 68,999, and then 69,000 or higher. Okay, so even though the salaries are numbers, they have created categories. You'll see that sometimes done with age. It'll say, what's your age range? You know, are you 20 to 29, or, you know, whatever age range they choose. Okay, so we have here you do actually have two qualitative variables. One of the phrases here that helps me to know it's test of independence is, does it have any effect? Okay, and you usually for test of independence, your data is going to be presented in a table. You have, like in this case, you have the major on the vertical and you have the salaries on the horizontal. So that if I look at, say, this square, that's 15 nursing majors indicated they made between $50,000 and $68,999. Okay. So again, the first step in any hypothesis test is to state your hypotheses. For test of independence, again, you still have the idea that the null has to be equal. And in this context, that means that the variables are independent. They do not affect each other. And the alternative would be not equal, which means they're dependent. They do affect each other. And that's basically what we say. We would say that majors are independent of starting salaries. The alternative would be majors are dependent of starting salaries. Okay, and here again, I've got to kind of scribble down my information, and you're going to have to kind of enter this. It's called a contingency table or a two-way table. So we're going to have to enter that information. So again, I'm scribbling it down. Okay, so I've got all, I've written down that table. Okay, so I'm going out to Minitab. Okay, and I'm going to get a clean worksheet. Now, for this test, the easiest way to do it is I'm not going to enter the majors. Okay, I'm not going to have a column for the majors, but I know that the first row will correspond to English, the second row engineering, third is nursing, fourth is business, and 5 is psych. I've got that going on in the back of my head. Okay, so the first column I'm going to put in is less than 50,000, and then I have 50,000 to 68,999 or 69,000 plus. You're only going to enter the columns. Okay, we don't put the labels for the rows. Okay, so I have 5. Whoops. Okay, so I have basically the table entered. without the row designations. Everybody okay? All right, then we're going to go out for test of independence. We go stat, tables, chi-square, test for association. Okay, Minitab doesn't use the word independence, they use the word association. Okay, I don't have the raw data. I have the data summarized in a two-way table. So my columns, I have to select all three of my columns. I don't have to do all this other stuff. I just select the three columns. Let me see if I need to include statistics. No, we don't need, it's defaulted. We don't have to change anything. So we choose the three columns and tell it okay. Now we get lots of information, but again, what we need is this chi-square. And I think maybe, because some folks have been missing this, so I think maybe, oops, that some people are misreading these results. I don't want you to do that. Okay, so here's my results. Guys, when we're doing this, you want to read this top row. Okay, we are doing Pearson. And I'm fairly certain that I tell you that in the instructions. Okay, we're doing Pearson. So my chi-square test statistic is 33.546. My corresponding p-value is 0. Okay. Then let's see, what alpha did they give us? Okay, they didn't give us an alpha. Typically, if they don't give us one, the default is 0.05. Okay, if they don't give you an alpha, the default is 0.05. Okay, so if we compare the p-value to the alpha, 0 is less than or equal to 0.05. So p is less than or equal to alpha. When p is less than or equal to alpha, we reject the null every time, all the time. Which again means in this context that the null is false and the alternative is true, which means the majors are dependent on the starting salaries. And so we would say, we would write our hypothesis, our conclusion as at the 0.05 level of significance, majors are dependent on starting salaries. We've said that there is an effect. There's some kind of connection between majors and starting salaries. Everybody okay? Questions? Okay, that's test for independence. We should have one more. Let me go over here to the questions on the quiz. Okay. Scenario 5 is the test for homogeneity. Okay, so do men and women. So let me get this copied. Okay, so this one is the chi-square test of homogeneity. Now, the challenge with this, because it also is presented with that table of information, kind of with that two-way table. And again, it also involves two qualitative variables. Okay, the question is, do men and women select different breakfasts? The breakfast ordered by randomly selected men and women at a popular breakfast place is shown below. Conduct a test at a 5% level of significance. So in this case, you have on the vertical, you have gender, men and women, and then going across, you have what kind of breakfast they ate. Okay, so again, it's two qualitative variables, and it's presented in that two-way table form. But again, notice this one doesn't talk about, does it have an effect? We want to know if men and women are different. So we're comparing two different groups, if you will. We want to compare men to women. I want to compare class 1 to class 2. I might want to compare, first year nurses to nurses who've been on the job 5 years. Okay, so it's still two qualitative variables. Okay. So again, the first step in any hypothesis test is to state the hypothesis. Okay, and again, your null has to imply equal, and your alternative has to imply not equal. So, and there's different ways to say this. We could say that men and women select the same breakfast. I was looking to see so that you'll be familiar with how they say it on the test. They say the distribution for breakfast preferences is the same for men and women. I mean, they kind of get fancy. Okay, so they're saying, so you're familiar with what it'll say on the test. It'll most likely say something like that. The distribution of breakfast preferences are the same for men and women. I mean, really what we're saying, if you want to get to it in symbols, which you probably don't, we're saying that basically the proportion of men equals the proportion of women. We're saying they're the same. So the alternative then has to say that they're not the same or they're different. So we would say the distribution of breakfast preferences are not the same for men and women. Now, Jody joked a while ago about y'all being teacher's pet. But guys, let me show you something, okay? Look. Okay, look at how these are worded. The distribution is the same. The distribution is not the same. Guys, even if you don't understand the problem, if you remember that the null hypothesis always and forever has to contain equal, and use, not to be rude, a little bit of common sense. Think about this, guys. Which one of these means equal? Is the same. So even if I don't know how to work the problem, I can still pick the correct answer by using a little bit of common sense that the null has to have equal in it. And then, guys, by default, the null can't be the same thing. The alternative can't be the same one. So the alternative has to be the other one. Or you have to remember it's not equal. But if I choose the one that said the is the same for the null, I have to choose is not the same for the alternative. Guys, and it works that way for all of them. Okay, it just takes a little bit of thought and remembering, okay, the null must always and forever contain equal. So even if you don't understand some of the process, if you use that knowledge, you can pick the right answer because you only got two choices. Y'all with me? Okay, so let me go back to this problem. Okay, so we've stated our hypotheses. And again, I've got to write down this information from this table so that I can go out and put it in to the computer. And you can, guys, you can shortcut it. I mean, you know, you don't have to literally write out, like I didn't write French toast pancakes. I wrote French pan waffle and oatmeal. Okay, you can, you know, enough for you to be able to take that information and put it into Minitab. Okay, so I'm going out to Minitab. Maybe I've got my mouse all catty-wonkered here. Oh. Okay, again, in this problem with that two-way table, we're not going to put the rows. Okay, I'm not going to put men and women. Okay, I'm going to leave those off. I know that the first row will be men and the second row will be women. What I do need is French toast, pancakes, waffles, and omelets. Okay, and then I'm going to enter my numbers. Whoops. Okay, so I got all my numbers entered. Again, I didn't put men and women. And guys, for this test, we use the same command. It's stat, tables, chi-square test for association. It's the same command in Minitab. Okay, again, I have my data summarized, and I'm going to choose the 4 columns. And then I'm going to click OK. And my results are going to come out. Okay, here again, we're reading the Pearson. Okay, it's the same command. So remember that you're going to look at the Pearson, and I think some people are maybe looking at the wrong one. So you're going to look at the top row here. My chi-square is 4.013. My p-value is 0.260. Okay, then we're going to compare the p-value, which is 0.260, to alpha, which is 0.05, because it told us to do a 5% test. Okay, so if I compare these, 2 is greater than 0, so p is greater than alpha. When p is greater than alpha, we fail to reject the null. Which means, in the context of the hypothesis test, that our null hypothesis is true. So the distribution of breakfast preferences are the same for men and women based on the sample that we have. Okay, so we would say in our conclusion, at the 0.05 level of significance, the distribution of breakfast preferences are the same for men, and women. Okay, and that's test of homogeneity for chi-square. So I started all that because DJ asked about the project. And so for the project, with whichever data set you're using, you can do any of those tests. Now you choose. In my opinion, chi-square goodness of fit is probably the easiest because it's only one variable. But you could do any of them. Jody, I think y'all are, Jody, have you been using the president's data for stat 2401?
Yes, ma'am, all semester.
So like you could do like a chi-square goodness of fit and say that all of the, political parties. Yeah, that's what I was trying to think of. Political parties are the same. You could do all the birth months are the same.
Yes, ma'am.
For Aubrey, are you doing supply chain or the healthcare one?
Supply chain.
Okay, so for supply chain, you could do, look at shipment modes. Are they all the same for chi-square goodness of fit? If you wanted to look at, say, the test for independence, you could say, is shipment mode independent of the country? I don't know who else is in the room. DJ, what are you doing? DJ, are you still with me?
Yes, ma'am. I'm doing a heart disease one. See, I didn't know what to put in the input, but I put age and then I put
okay, you cannot do age because age is quantitative. You have to have qualitative. So if you're doing heart disease, you need to look at something like there's one that's like a true false, and exercise angina, I think, is a yes, no.
Yes.
You could do gender and the thallium level or something like that. Somebody asked earlier, I think in a discussion about the number of categories. Guys, for chi-square, there's no limit Okay, you have to have at least 2 categories, obviously, to make a comparison. But you can have 2, 3, 5, 10, 100, 200. I mean, you can have as many categories as you have for that particular variable. Most of the examples, I think, that you see in the course had probably 3 or more, but that's not a requirement. You could have 2, so you could look at gender.
So once again, I did hear you say that the homogenic and the independent steps for entering the information to Minitab is the same, correct?
Yes, sir.
All
The
right.
difference is, okay, the difference is the statement of the hypothesis. But the command in Minitab is the same. It gives you your chi-square test statistic and the corresponding p-value. Other questions about chi-square? Do you have other questions about normality, one mean, two mean, proportion test, Anova?
Could you go over Anova, please?
Okay. I couldn't tell who was speaking, but yes, I will.
Okay, thank you.
All right, let me get out of this one. And I can go back. I believe I can go back to Anova. You probably can't, but I can. Okay, with Anova, okay, a couple of things about Anova that make it different from chi-square. Okay, Anova, you must have at least 3 categories. Guys, there's kind of a hierarchy here, okay? To kind of think about this with quantitative data. If you have 1 category, you're going to do a 1 mean Z or a 1 mean T if you have 1 category. If you have 2 categories, we did 2 mean T. So if I wanted to compare males to females, okay, and I only have 2 categories, because biologically there are only 2, then I have to do a 2 mean T test. When I get to 3 categories, that's when I'm going to do an Anova, specifically with quantitative data. Okay, so that's the difference, because some of you, when you did your project for Anova, you used something that only had 2 categories. And guys, that doesn't work. You have to have at least 3. The other thing that's different about Anova is we take a quantitative variable and we sort it by a qualitative. So this is one that kind of, it looks like you've got, you know, you do have 2 different variables. One is quantitative, one is qualitative. We're taking the numbers and we're sorting them into categories. Okay, so if we look at this first example, this is from quiz 9. That was where we encountered Anova. And let me see about copying this. It says an administrator in admissions at GHC is worried that certain majors have more hours earned than other majors. using the majors and hours earned data below, are the mean hours earned similar regardless of majors? Use a 0.05 level of significance. Okay, so we have the categories. Again, if you look here, it gives us majors, which are going to be words, and hours earned, which is going to be a number. Okay, so we have quantitative sorted by qualitative, and you can even see that in the way that it's displayed. Okay, because you have general studies, nursing, and business. Those are your categories, those are your words, and then next to each one we have a list of numbers for hours earned for the students that were sampled. Okay, so that's one thing about Anova. So again, like it is the case, and I'm gonna have to have something to drink. I'm losing my voice here. Hold on. Okay, as is the case with any hypothesis test, we're gonna start with our hypotheses. And again, you have to remember the null has to imply equal, and the alternative implies not equal. Now again, there's lots of ways to say it. I want to show you how they have it worded and how you'll see it on the test. And again, guys, if you use a little bit of common sense, remembering that the null must always contain equal in some form, even if you don't understand the problem, you should be able to pick out the null hypothesis, because your options are all the mean hours earned are not the same for the majors, or all the mean hours earned are the same for the majors. Okay, so null, it has to be are the same. And so by default, then the alternative has to be they're not the same. Now, again, there's other ways to say it, but getting familiar with how the words are going to be on the test may be helpful to you. Okay, so we're going to say all the mean hours earned are the same for each major. Now, again, not that you have to know this, but you could write that in symbols, because we could say the mean for general studies is equal to the mean for nursing, which is equal to the mean for business. We're saying they're all the same. The alternative then would be that they're not the same, or at least one differs. All the mean hours earned are not the same for each major. Okay, again, that idea of it's equal and not equal. And so again, I'm going to scribble down my information. My categories are general studies, nursing, and business. 28, 70, 71, 74, 17. The biggest part with this is, of course, making sure that you write the numbers down correctly. I would tell you, to kind of double check yourself. Okay, so then we go out to Minitab. Now notice this information is displayed horizontally, but anything we put into Minitab, we put in vertically. Okay, so when I go out to Minitab, get me a new worksheet. I'm going to put it in columns. So in column 1, which is row 1, I will have general studies. Row 2 becomes column 2, which is nursing, and row 3 becomes column 3, which is business. And then I enter the numbers. Whoops, got to remember to hit enter. Okay, so I've got those numbers entered, and I go back, start for nursing. Now, in this case, we do have the same number in each group, but guys, to do Anova, you don't necessarily have to have the same number in each group. It's okay if you don't. We do for this problem, but if you didn't, it would be okay. The calculations take that into consideration going on behind the scenes. Okay, so we basically have entered the information. We entered it vertically as opposed to horizontally. Okay, so this is Anova. Stat, Anova, one way. Okay, we didn't make the decision. Let's see, response are in separate columns. I have each list in a separate column. So I have my general studies, my nursing, and business. I choose all 3 columns and I click OK. What I'm looking for is my analysis of variance. Okay, the blue header labeled analysis of variance. And what you need from this display is your F value, that is your test statistic, and your corresponding p-value. So my F test statistic is 0.31. The corresponding p-value is 0.738. I'm then going to compare that p-value to alpha, which I believe was 0.05. I'm going to double check. Yep. Okay, if I make that comparison, 7 to 0, 7 is greater than 0, so P is greater than alpha. If P is greater than alpha, we fail to reject the null. Okay. Again, if we fail to reject the null, that means that our null statement is true. So all the mean hours earned are the same for each major. Okay, so that would be our conclusion. We would say at the 0.05 level of significance, all the mean number of hours earned are the same for each major. And there you go. That's an Anova. I'm not sure who asked me about that, but does that help you?
Yes, ma'am. Thank you.
You're welcome. I just can't see who's speaking in my window.
It's Amaria.
Hi, Maria. Other questions from module 3, module 4? Again, normality, 1 mean, 2 mean, 1 proportion, 2 proportion, Anova.
I have a question.
Yes, ma'am.
You said on the hypothesis test, we have to determine if it's a Z or a T test.
Yes, ma'am.
Is that where we either are given, I believe it's the population mean, or we're not given the population mean, or am I confusing that?
It's the population standard deviation.
Standard deviation.
Okay. If you have, and I'll share my screen again and make notes for you. Well, okay, the difference, if you're doing a 1 mean, I don't know why it's doing that, hypothesis test, you have to decide, should you do Z or should you do T? For our purposes, for our class, okay, here's the difference. You know the population standard deviation, which is represented by the Greek letter sigma. Okay. If you know the population standard deviation, you're going to do Z every time. For T, we do T if we know only the sample standard deviation, which is represented by S. Now, occasionally in a scenario, they will give you both. If you have both, you must use the population standard deviation, and therefore you would do a Z. But that's the difference. Now, there are other criteria that could be used, but for our purposes, that's the distinguishing factor. Is that good, Aubrey?
Yes, ma'am. Thank you.
You're welcome. Other questions? Okay, a couple of things let me remind you. One is, in both classes, quiz 12, mini project 7, and discussion 4 are due tomorrow night at 11:30. The final opens Thursday morning. I mean, it'll open at midnight Thursday, and it stays open until Monday, August the 1st at 11:30 p.m. You need to plan at least a 3-hour window, consecutive window. You can't start, stop to take it. And please, oh please, oh please, don't wait till 8:30 Monday night, because it will cut you off at 11:30 p.m. Otherwise, if you work beyond the 3 hours, it's just going to send me a notification, which is not the end of the world. You can use your notes. You can use the PowerPoints. You can use practice problems, homework problems. You can write, have examples. Again, I mentioned at the beginning, and Jody even asked, it is in the order that is listed on the document that's in D2L. I strongly suggest that before you attempt the final, that you at least attempt the review. You're going to get 10 bonus points for making the attempt, but that's also going to give you great insight into how the questions are worded, the ordering, all that kind of stuff. Any other questions?
No, ma'am. Thank you.
You're very welcome. Y'all have a good evening. It'll take probably an hour or so for this to process, but I'll try to get it posted either late tonight or first thing in the morning.
Thank you again.
You're welcome.
Thanks, Professor.
Thank you.
Brandy.
Thank you. Yes, ma'am.
Do we need to chat for a minute?
We can for just a split second. It won't take long if you got.
I do.
I had to cut a light on in here. I was listening to everything, and I as soon as he made mention of the mini project about the qualitative and quantitative data,
yeah,
I realized that I jacked that one up. I know what to do with it. I was looking for a number, and I wasn't thinking today like the number is actually, because I'm doing the presidents.
Yeah.
And I was like, the